Alright, so we have finally finished the compiler, like the basic part, right? And covered like all the tests that I could think of. And I think now it would be a really cool idea to extend the language a bit by adding a standard library to it. Like, let's say, for example, to implement Linux syscalls as an OOP class. That would be really interesting. But first, let's see, I guess a small example of the language. So let's do all of the files in here. Let's create a main.cl file. This will be, and yeah, I added like um, off screen. I implemented a kind of a better build tool. I created this build context class. You can see like it has a list of all the user programs. It might sound like you can have actually multiple files, and yeah, that's actually you can have multiple files. It also has the paths to the like standard library of the language, and by default it will look for the lib folder in the current folder, right? So yeah, it's I'll have to find a better way of doing this, but for now it's let's add it to do find a better solution. But for now, I thought that, well, just search for the cool home environment variable, and that tells you where to look for the lib folder. And inside of the lib folder, it's a kind of a glob from Python, but not really. It's more scuffed, I would say, um, because it only looks for the current in the current folder. I might have to do here search for nested directories because I don't. I just look for, I mean, I don't even check if they are files, right? I just read the entire directory and that's it. But yeah, basically we'll try to do like a glob from Python, like os.work if you know Python. And yeah, I guess the better build system was just making small functions with I guess, each part, right? So we have well, I guess I can go in the main function. It's easier to visualize it. We do first we parse the prelude, and we don't print anything inside of that. We just parse the standard library files, and that's it. If you get an error here, it might be because my fault, basically. That's the idea. Then we parse the user files, right? And here, like obviously, if you make a mistake, it will stop here. Then it's the gatekeeping part, which is the semantic checks for typing and stuff like that, because it like the cool language allows um, static type checking. So I mean that's a really cool feature. It's really interesting to implement this kind of feature. And then for code generation, we iterate all the expressions, convert them to intermediate representation, and then each instruction we convert it to assembly. So yeah, and I guess the compiler stops there. You have to use Phasm to uh, go further, like from assembly to executable. So maybe call Phasm here, I guess, to not worry about having to call Phasm manually, but I mean, yeah, that's optional, and obviously to do memory, like we don't free any kind of memory. I think maybe we free some, but like 1% or something. So yeah, that would be like what's missing, I guess. But yeah, it would be really nice to have Linux syscalls in a class, I think. that sounds interesting. So yeah, let's go back to the class main. Let's see, so we are gonna have a main method, right? As usual, it's gonna return object, right? And yeah, I'm not really sure what it should do. Maybe, I mean, I guess I have a main function already, so I guess we can try to implement the list, right? Something like that. So let's go in main.cl class list, and the list is gonna have an the item, so item which is an object, and next which is a list, right? That's how we build a linked list, right? And usually in C you would have an append, right? So append method which takes in an object and returns a new list, right? Or I guess it returns, I mean, makes sense. Wait, just 1 second. I guess, yeah, it takes in, it's more like, I guess it's more like cons than it is. Yeah, let's call them I and next. Do not shadow the, and this should return self type, and basically it just initializes the stuff. And I was thinking that maybe if we had a method, yeah, but I mean it's still fine to call it like this. Like if you can call append with just an item and it does cons for you, basically. So append, and it has a list, right? So how would append work is we would have to find the ending of the list, right? And so I would do something like while not is void next, right? While not is void. Well, I guess we cannot really say. Like, sure, if we have a method next, that would work, right? And also declare a variable. So maybe like let iter list is gonna be equal to self, right? And then we do in, and here we should have a block. I think we are gonna have multiple instructions, but yeah, while the iterator is not void, then we can do something like iter. Let's have a next method which just returns next. Iter is gonna be iter. We don't need we need it here. So here we iterate until, but this will put us on void, right? So we have to call next here. Oh, and yeah, it's loop, not it's loop, and here should be pool, right? Something like this. So while this is not void, we iterate. So now we are on the last element of the list. So yeah, I mean maybe it's easier to do it recursively, because we cannot really, I mean, set, right? You would have to call cons. So yeah, let's try to do it recursively then. Okay, so if basically if is void next, then next should become a new list dot cons I, and here void would be basically next, that we can reuse is void, I guess. Or maybe not, because yeah, let v list in, so this would be void. Okay, else we just I guess we just have to call next append and not do anything. But also this one should return self type, so this should be a block like this, and then return self at the end. I think this is how append looks like, right? Like we have the base check, right? If we are on the last item, we create a new list. Yeah, and we assign it to next, to this field. Otherwise we just iterate. Yeah, something like that. And at the end we return self because we want to have the start. Okay, I guess. And I mean, I'll just copy the print from here. Now yeah, print is the only method that I guess sucks. But yeah, not really, because we can do print in here. So it's gonna be, print is gonna take in. Okay, so we have next and item. is going to return the item, right? You can have these accessors to our fields. Yeah, and print is going to take in an object, so it's going to take in an item object, and here maybe we have x is int. Oh, yeah. Okay, that's good enough. So let's say this inherits IO, just to have out string and stuff. I mean, it just prints this. We don't need anything else, and it's just the let statement. So yeah, basically like this. Let's create let. Let's create a new list just like this. Well, you have to also do void is list. Basically, when you don't initialize an object, it's gonna be set to void, right? So that's the main idea. And here, let's try to say something like list. I mean, we can do this, right? And list shouldn't really change. Let's initialize an iterator with list. Maybe while is void iter loop. Okay, something like this, but here we print iterator item, and here we do that. Yeah, so let's just remake everything, build the main, and if we try to check the tokens, everything is fine. But let's go straight to ASM because it will tell us if we have any syntactic errors. So online. Oh, yeah, you have to put the semicolon after you finish method definition. I'm really close to removing that feature because it's annoying. Line 14. I mean, these errors, the syntactic ones, are the worst. I'm not really sure how to do it like really well because I implemented the parser from scratch. I haven't used like parser generators. So and yeah, this thing means that I missed something in somewhere in the implementation, so that sucks. It's probably that I have a bug in the code. So because here it's value doesn't even exist, so I missed something here, right? Okay, so now it works, but there's something wrong wrong with the case statement. I'll check that one now. Like if I used here F or something, it didn't complain about it. Right? I guess I forgot to check that the variable from yeah, to be honest, I don't know. But probably I forgot to do some static type checking inside of case. So yeah, but I mean things work, right? So if we put, and yeah, this is how the assembly looks like basically. I mean there's nothing special about it. It's just a FASM assembly, but it's gonna combine the prelude assembly with our code, and now we can say something like main.asm. Then we can call FASM on this, and if we execute main, obviously we get segmentation fault. But maybe it's because of that, so let's try again. So FASM main.asm, still segmentation faults. I mean, even if we do just a single print here, let's chain all the commands. Even if we do that, that's really curious, because like we have the exact same thing in the other place and it works fine. Wait, what? Like we have a main.cl file here and it's completely fine. That's so weird. List init. I mean, the list init is the same, right? So I don't see what's the problem. I mean, we don't even show it. So we don't call out. I mean, we do call out string. But we don't really do out string new line. So if we get segmentation false, well, if I do hello, like this should work. Like there's no issue with it. But yeah, what? This one. Okay, I'm really confused about this one. Let's have a print function here. So it is gonna return a self type. Okay, let's take this one And let's just try to print the item on this. So if I do list print, it should show the first item. I mean, well, not really. Let's say new IO. So it's gonna be IO. Still doesn't work, so what the heck? I mean, the last option is... I don't get why it's not printing anything. Bruh. I mean, let's just copy paste this thing instead of this crap. Let's remove the person because I don't care about that right now. Let's have the print on the thing itself. Let's remove these classes. This is so strange though. Okay, I mean, wait, what? Oh, I think... No, but why doesn't it show... Oh, because I did print F. Oh my god, yeah, I guess I was doing... I guess I was printing the errors. Yeah, I might have to change that and do print the errors to standard error instead of STT out. But, so here let's do a second. First second, okay. And now let's take the print, right? Let's move it in here. This doesn't need to be IO anymore. Yeah. So I think the printing should be just printing the item. So there is gonna be object. And let's say value is gonna be a function, right? Okay. Where did this happen? Line 32. Okay, because I put the extra... Well, I mean, it's gonna be like this at some point where we when we actually fix it. Okay, so this works, right? So my second idea was to have a while not is void L. We're gonna loop, we're gonna pull. We have to iterate like this. So that means we also need a next, which is gonna return a list. Oh, I think I know what the problem was. I need to like I don't get why Copilot was it's so dumb. Why did L equals L next before printing? Like that's not really specific to this language. It's like in any language you have to do that. Okay, another error. 44. Oh, because this returns IO. For a second. Yeah. And here let's say out string new line or something. So now we get the items, right? So it works now. That's very interesting. So let's put append back. So append is gonna take just an object, right? So it checks if next is void. If it is void, if it is void, then it has to create a new list, initialize it, set the value, and void. Well, we don't really have a void list. In, yeah, we have to create the void list. We do it like that. Initialize this with v and void, and we assign this here. Alright, otherwise we recursively call to append. That's good, and at the end we return self. So now if we say something like L append third, we don't even need to reassign. Okay, I forgot to do something. Line 27. Okay, so now it works. I have no idea what was wrong before, but first, second, and third, right? So now this list is a bit better. We can append items to it, and we have initialize. Okay, I mean, you know, while working, I guess, with the language itself, we find small to-dos like printing the standard, printing the error to standard error. That would be nice. I guess we can have like a list of to-dos here to do. Print errors to stdr. To do add phasm in build tool, because it's annoying to always have to do this, right? But you know, okay. So the next step, like just to showcase that, is let's move out this into list.cl, right? So now we can say compile these three files, and I guess let's just do it like this for now. So you see it compiles it, and if we do syntactic, it generates an AST for each file. So yeah, the only thing I wasn't sure about is, do we want to concatenate them and show the AST for both at the same time, or show different ASTs? I went for showing different ASTs. No, maybe implementing an LSP? No, I mean that would be not ideal. So we get the same result. That's really nice. So yeah, now let's I guess we can take this list, right? This list implementation, mark file, mark target, and now we should have the list implemented as a prelude, so we don't even need to add it anymore in the compile script. So now we have list available anywhere, and yeah, I think that's nice. I mean, the list is pretty lame, so we can try to improve it, like adding access to an index, or maybe allowing the user to set an index or something, get the length of the list, stuff like that. But let's try to go ahead and implement a class Linux, and let's see, man, syscall. I was curious to see if there is a table with the syscalls. What's this? Don't know, don't care. Interesting. It doesn't have anything. Okay. Linux syscall table. So I don't think it's possible to implement a single function. I think we have to implement every function basically. Right, so it would be, let me just check. I think, yeah, we need to implement every single function. So this is Linux interface, right? Is responsible for calling syscalls, I guess. I don't know. But we're gonna have like read, right? And how, I guess, man read. No, to read. So it takes in, see, like file descriptor. It's always gonna be standard input. We don't really have an option. We're gonna hard code it to 0 or 1, I guess. Standard input is standard input is 0, right? I don't remember. std. Looks like it's 0. I'm really surprised that it's not here. But judging by the order of them, it's 0, right? 0, 1, 2. Anyway, so it takes in the file descriptor where we are gonna write and how much we are gonna read, I meant. So I guess how this function will work, right, is that it's gonna take in a number, like how many bytes we want to read, and it's gonna output the the string, right? So that's my idea. So let's say it's gonna take in because if you say like file descriptor, that's, I mean, it's possible to have file descriptor, but it's always gonna have to be 0. But I mean, let's give it the file descriptor. Let's give it Oh, that's interesting. Bytes. I mean, we are gonna read into a string. It's the same thing, pretty much. Because yeah, for us, like a string is just a sequence of bytes. Okay, we're gonna pass in the count, and it's gonna result a string. And usually you would implement it like this, but we can say extern, and yeah, this is how it's gonna work. Okay, let's see. Write is gonna be similar. Let's copy it. Let's do write, but I see it takes in a string here. So it's gonna take in a string. So it's gonna take in a buff because the string contains the length, right? But maybe you want to write only a part of it. Well, I mean, it's your job to use substring, I guess. Anyway, and what should this function return though? I mean, even read it returns size t, right? This one returns size t. To be honest, I would return self-type. And like maybe it's not like the syscalls directly, it's more like using manfread, right? It's like maybe the libc version rather than directly interacting with the syscalls. Because even for write, if it doesn't write everything, I mean it should return an int. And here when you read the string itself contains the how much it contains. So you can check if it's count or not. So that's easy to do. And maybe this one then it should return an int. So yeah, I mean let's try to implement these two methods first, these two functions, and then we'll see about the rest of them. I mean, if it's possible to do more or something. So yeah, let's go into the assembly and let's go ahead and have similar comments. Read syscall. So basically, the input is gonna be similar. Rx is gonna contain self, right? And the stack is gonna have the following. So Linux is gonna have the file descriptor and the count. So it's gonna be not like that. It's gonna be. Did I use? It's pretty weird. Anyway, tree ident. So file descriptor, um, which is gonna be an int. We don't have pointer, so yeah, we have to return it. Then count, which is gonna be an int. And output, not really. So output, args points to the string object that is created, basically. So you know the drill. If you already seen me do the assembly, we just copy paste this stuff, Linux read. Let's copy paste the end of the thing. So in here we are gonna need to actually do the stuff. So similarly to this guy, I mean, we are going to be interested in the heap position because basically, but you know what, like we have in string, maybe we can reuse parts of this. So we create a new integer, right? We create a new string. So maybe we can even have more than, I mean, let's just copy paste everything because this is really similar to what we have. And we are going to replace in string with the syscall for read. Basically, that's my idea. So here we have a new int object, and this new int object is going to be the length, right? How much we read. Then we create a new string. Then we took the pointer to the start of the string twice because we want to check, like one pointer will stay here, like it won't move. The other one will point to the end, so we can compute the length after the read. Basically, T2 will be the start of the string, T3 will be the end of the string. So that's the idea. So here we have two variables. That's really important to know, right? So if T3 plus how much we want to read len, I guess read len is what? Oh, read len, I guess it's a global variable of how much we can read. We'll see here it's gonna change then, because we are gonna read only once or something, so we are not gonna have an again. We are gonna say T3 plus arg 0. So here is where it's gonna diverge a bit. So since count is an int, right? Let's put it like this. Let's do T4 is gonna be arg1 dot value. So we move arg1, we take the int slot, and we save it. I guess we save the value itself. So we do move rx. Okay. So now we can compare this stuff. Right? We can compare T3 plus T4 with a heap end. Right? And if it's I guess not enough memory, we allocate 64K, like a single page or something. I guess it's, I don't know, just the standard for cool probably to allocate a single page. I don't know. So then we have that, right? So now we are gonna do something like this. Let's see. So in T5 we are gonna store the result for the read syscall. So we are gonna do read. So this will be T4, T3. I mean, here it doesn't really matter. It can be T2 or T3. Oh, what's even more interesting, I don't think we even need two pointers to the string. Yeah, we don't even need that, so let's remove that. So here is gonna be T2 and T3. So we're gonna have T4 is, well, we can actually have T4 is gonna be arg0.value. Right. So we are gonna store inside of T4 the file descriptor, but only after this place. Right, so it's like we create a new int, we create a new string, take the pointer to the string, take how much we want to read, see if it's enough. If it's not enough, we allocate more memory. Then we take the file descriptor into T4, and here we say T4, this is T5. So I guess RDI is the first argument, so here we have to move T4. In RSI we do the pointer to our string, and inside of RDX we have to put how much we want to read. And the syscall for read is 0. Okay, then we do syscall, and here I said that we save this here, but why not save it directly into T0? I mean, I guess let's just save it into T5 for now. And then all of this part is, I mean, this part is useful at the end, but we'll see what's not useful. So now we have to say that T0 dot value is equal to T5. So this is well known how to do, I think. Yeah, Rx is the int slot. Now I have to move into RDI, we have to use another register and store the value. Alright, since T2 is a pointer to the string inside of T1, it's already written there, so we don't have to worry about that. Alright, so next would be to delete all of this useless stuff. We set T1.L to the pointer to this, so as usual. Then inside of T5, which is already taken though, so let's do T6. Right, so T6 should be, I guess, the size, which is in T5. So we can do here, we can do T5. Right, and here we did the size plus 7, then we divide by 8, so this will seal it, right, because we add the modulo, the maximum modulo basically, and then we multiply by 8, so it's gonna be sealed. I think that's how you do it, but anyway, we store that value in here. right? Maybe we can just do this part without shifting to the left, so that here when we store the size we just store T6, so T6 we don't have to shift, right? So as I said, since this one is kind of well known how to do, it should be like this. It's like the same as assigning a value. We take the pointer to the object, we take the pointer to its field, we take the value that we want to assign, and we assign that memory to that value. And now we should increase this by doing shift left. So here we, why did you add 7? Because T6 is already moved. So we have to just shift left RX3. Because I said why do it twice, right? So this should be T6, like that, and here we store that. So we actually used 7 variables, so this should be 56. Deallocate. I mean, it's annoying that I still have this as a number, but doesn't really matter. So we have this syscall for read. Let's just quickly mock the syscall for write and try to use this one, see if it's, I mean, if it doesn't work then it's pointless to, but I mean it should work. Let's add a to do. Like right now this doesn't do anything, the write syscall. So let's just save write. Okay. So if we go back to main.cl, right? If we do here like what? Linux.read from 0, and let's say we want to read 10. Like this is the only issue with Linux read, is that it's gonna read some value, right? So yeah, so we'll have to see. Alright, so if we recompile the program, it failed, obviously. So unexpected talk, oh, it's new. Let's see. Okay, perfect. So it wants to read, let's say A, B, C, D, E. Bruh. Oh my god, this is so cool though. See, like if I do a lot of A's, it's gonna read only those, and here it's gonna put the rest on the next line. So that also means that we can pass in how it's called, hello. Oh, it also goes okay. Like if you pass Control D into it to have the exit, or how is it called, end of file, right? This is cool now. Okay, I guess it means that we can go ahead and also implement the write syscall, which gets in a file descriptor a string and an int. So it gets in file descriptor the buff, which is a string, and it outputs points to the int object containing the number of bytes written, containing the red string. Okay. So writing, we have out string, which we can probably copy. Right. I mean, this one is much easier to do, I guess. Okay, so let's remove the start and the end. We didn't even allocate. I mean, we are gonna require to allocate some variables, so let's just keep that right there. So we are gonna need a new integer, at least. Right? Then let's say t1 is gonna be arg 0. Well, yeah, it should be. Let's say it's gonna be the file descriptor, why not? So it's gonna be the file descriptor. This is the int slot. Take it and we store it. Then inside of t2, let's put the string. So it's gonna be similar string field. We store it. In t3, let's put the string size. So we do that. We take the int slot. We dereference it again. Yeah, and we save it. I think that's how we do it. Oh, I mean it was on the on this line. So yeah. Okay. So I guess we have everything. T1, yeah. So if we take a look at man to right, it's gonna be file descriptor, buffer, and count. So I mean, just to keep the order, we could have done this. But doesn't matter. So then we need to put in T4, we're gonna put the syscall. So we move RDI, RSI. Wait, why is it like this? Oh, it was right. What the hell did I do? I don't know what I was thinking though. Okay. So T2 and T3. So yeah, this should be how we do it. We put that value there. Here we set okay like this. Yeah, it's the same thing as we did usually. I mean, yeah, it's like I really like to have these repeatable copy pastable chunks that I also have in the, like when I convert the instructions that look like this into assembly. So we don't have, no, we don't need that. I think we just need to return it. Let's see how we did returning this one. So we moved into RAX, the thing that we needed, which should be the new integer. So which is at 0. So we just return it. So here I can say like T0. here I would say T1, return T1, yeah. Return T0. Okay, perfect. So now we also have write, sorry. So now if you go into main.cl, and let's say we do new linux.write, we write to std out hello world after each, yeah, it should write it. I guess this is interesting. To prelude.assembly. Oh, I haven't. Okay, yeah, it works now. So, yeah, basically now we can do syscalls. Like instead of having to rely on our functions, and that means that now we can implement, let's say, the in string and out string using the syscalls. So we no longer have to write assembly in here. I mean, copy probably still gonna be here. It's not really gonna change. Abort as well, I don't know. Probably type name also, I guess, I don't know. But like out string should be implementable using the right syscall. So let's just make a small commit. So for for these two, then for the assembly in main.c I just added those to do comments, and in util, okay, feature add syscalls. That's really nice. So now if we go to prelude.cl, right, what would happen if inside of this guy we would have a Linux of type Linux, new Linux, why not just save it as an attribute, and here let's do linux dot write 1x. Obviously this shouldn't be a thing, so we just need this thing, okay, and we return self. So this should throw an error, say that we redefined. That's strange. String.out, no, io.outString. What? Like, yeah, isn't it redefined? Strange. I guess it doesn't matter in oh yeah, it doesn't matter for us, but when we are gonna do Phasm, it's gonna complain about that. It's already defined. Okay, so if we go on prelude.asm, we search for out string, we no longer need you, so goodbye. Perfect. So if we rebuild this, we have the hello, and I mean it still works, so that's really nice. To output an integer is going to be a bit more complicated. We need to convert the digits to letters. I guess that's, yeah, that would be interesting to do. We'll try to do it. But let's change in string now. So in string, it's gonna be just Linux read. And if we go into linux.cl, read requires a count. So yeah, that's gonna be interesting because it requires a count. So we should probably, because if we check out how it did in string, we also did read again, and we read for read length. So read length is 124. So let's say we read 124, but we have to repeat this step multiple times. So let's say let s is gonna be a new string, right? And we are gonna do in and yeah, we might need a block. So we should say something like this. For now it should work, but we are gonna require a while loop here, and we need to say s.concat. It would be so cool to have, but we should concat it, right? And not just concat. Let's have two strings. So we're gonna have the main string that we build and the temporary string in which we read like this. Here we say s.concat and then we return s. So this will be inside of a while loop, right? And it's gonna be like a while true, and we'll have to check if TMP contains, I guess, a new line. Or like here when we did in string, we, where is it? Where is the again? Okay, so here is the again. So we just took yeah, so I guess the read syscall, okay, yeah, it gives us the length, so we can access that. Like we have access to the length of the string. So that's good. We have access to it. Yeah, we just have to check that the last one is not equal to like new line. Let's see how we can do that. So let's say we read 10 bytes because here we did -1. Okay, yeah, it makes sense. So it's gonna be, oh, but we cannot have a while true because we don't have return. Well, I guess we are gonna do temporary equals to this. We are gonna concat it straight up, and then we need a while guess while tmp.length is equal to 1024 also makes sense to do. Like while you read fully, you go again, but it's not really in the spirit of in string, which should read until new line, right? Like that was the idea of in string. But I guess even the read syscall read until new line, so it shouldn't really be an issue. So let's delete this. We can afford to delete it now. Something is broken. Ooh, something's broken here. So yeah, I mean the language is simple enough that it doesn't matter that the error is like complete bullshit. So like just the first error is important for your information. So it's 74. Okay, we just forgot a comma and it was spazzing out because of that. I really have to do a better job on that, but okay, it still works. So I guess that means we have this. Okay, perfect. So we also have ink string now. So we just removed both of them. Interesting. I guess I forgot to say that we did, but I mean read write implement read write syscalls. Okay. So as I said, would be interesting to have man, like the syntax is really bad on this one. I don't know why. So it would be nice to have int to string. So why not just go on the int object and maybe have a toString method. Like that makes sense to me. So the to the toString method return the string. Yeah, I mean sure. I mean toString can be a method on object. So, right? The toString method returns a string representation of the object. Returns string. toString, but for an object, I don't know what it does, right? I don't know what it does. It can be like self-type name, maybe concat object. Make it like, I don't know, JavaScript. It says it's an object. Anyway, we have toString, right? So IO shouldn't really worry about toString. Obviously, if you do toString on this it returns self. To be honest, I'm really annoyed by the comments. They are really like annoying when but I mean they would be useful for someone that goes into this. But like, isn't the name of the method really enough? Yeah, I don't know. So toString on the integer object, toString is gonna return a string. And how is this going to work? Mm, yeah, we should do something like let x is gonna be int, but we cannot do self directly because self we cannot do that. I think we cannot do that because I also tried it here and it didn't work, I guess, because it's gonna be self type. It's not gonna allow us to do math operations. So what we have to do is do a case self of me, and if it's not, we have to abort it. Like if it's any other object, we have to abort. And then suck. Exactly. I mean, here also would have made sense to abort because this is unreachable, basically. Like me cannot be any other object than boolean. So I can also do abort false. Right, it doesn't make sense to have that. Yeah, like the comments are a bit annoying on this one. Like from inside of Vim, so I might just delete them just because it's I guess it's a bit distracting, right? When I scroll up and down and it's yeah, I mean it is what it is. It's I would say it's pretty self-explanatory what the methods do from the name and the arguments, and I mean that's enough for me. It says me it's distracting who has files of 2000 lines of code. Yeah, but I mean when it's like just code, it's not really distracting. But what's distracting was the changing in color, right? Anyway, so I think this cannot really be anything except external methods, right? This will change right now. Also this. So let's have, I mean, probably length. Yeah, this cannot really be, again, these should be external methods, I think. Yeah, no, we'll see. So this just returns self, although again, this won't work because it's self-type and self-type is not string. Mhm. So again, this should be like case self off, right? I think that's the only way to do it. So here it's it's gonna be like that. Let me just, I would just do it like this, I think. Yeah, okay. So here we get an int. Do we need anything else? Probably the string that we build. So we're gonna have a new string, and then it's gonna be in. Well, concat int, that's a really funny function. Yeah, like that would be a really good function, concat int. It's actually surprising that we got something useful out of Copilot. That would be a good function to have, concat int. Yeah, let's do it. Concat int. It's gonna take in an integer, right? Again, this won't really work, but we can call self.toString, or I guess we can call toString on the object itself. So well, I guess we can initialize it with toString, so we don't have to worry about it. Recursively calling to itself. So the idea here would be to maybe have a while n is greater than 0. So I guess while n is greater than 0, we should, but we might need modulo. So let's implement modulo, I guess, on the int. So this is going to be mod. We take in another int. So how modulo works is, well, I guess you saw a glimpse of it in the calculating the size, right? So if we divide a number with another number and we take the like integer division and then we multiply back with that number, we get the floor, right? And if we subtract the floor from the number, we get the modulo. So I think that's how we do it. I don't know if it works for negative numbers. To be honest, I don't know how mod works for negative numbers, but for our purpose, I think it's enough. For doing, yeah. So while not n is equal to 0, we are gonna do a loop. Then we're gonna do a pull to stop the loop. So now we need the digit. So this is going to be a digit. right? So we say d is equal to n mod 10, and now it's gonna be interesting. It's gonna be a bunch of if statements, like if d is 0, then yeah, I'm wondering how I can arrange it nicely. I think, yeah, I really like how Copilot knows how to do it. Else abort table, and then we have to feed multiple times. Hopefully it's enough. So yeah, basically we want to create a new digit, append it before the string. So probably then this should be an empty string. So this should be a new string. Right, we appended all the digits, but we need to also do, wait, no, n is equal to n div 10. And at some point n is gonna be 0. So it's gonna stop the loop. Inside of s we are gonna have the number as a string. So the next step would be, after the while loop, I think we should concatenate no. We need to do string concat s and then return s. So I think this is how we are supposed to concatenate an integer to our string, and at the same time, if we do okay, I guess this one can be like this, and we do new string concat int x, so it's gonna be just the x string. Okay, and if we do toString for boolean, we have to do it like this. Yeah, good enough. Still with the case. So I mean, I guess we should check for any errors. So on line 8 instead of prelude. Okay, I put semicolon there. Still line 8. Still on line 8. Oh, I mean, obviously. Line 64. Oh no, oh no. Expected else got L parenthesis. Well, why? Do I keep trusting ChatGPT? Okay, expected phi got semicolon, so let's see. We have 1, 2, 3. Well, we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. With what? Is it because, yeah, it's because of this semicolon. Okay, and on line 102, it's without a semicolon. 134. Again. Oh my god. Interesting. I mean, obviously we don't do anything with numbers right now, so we don't know for sure. But that means that we can implement out integer using well, I would say here I would say out string and just convert x to a string, right? And then in int should be let s. Oh my god, why is it so overcomplicated? Oh, because we don't have I mean we have concat int, we don't have the reverse, so it should be mm, I mean maybe you can have a parse function on the int on or a parse function on the string, like have a toInt function. So we have I mean concat int is just the helper method. I guess this entire thing should probably be hmm I don't know if it should be on this one. It feels like it should be. So let's just take this entire piece of code and somehow fit it inside of this. So we are gonna remove that part. Right, we have x is the number, we have s, so this should be x. X is the number, s is the new string, n is the number, d is the digit. So I think here we just return s as it is, and toString now is actually on the int where I think it should be, so we don't need that. And let's say now we have a toInt method on the string, and we might want to do something like this. So let's remove the contents of that and let's see. So we are gonna do still a let statement. Let statement. Obviously we need s, which is gonna be string case. Okay, like this, similar to this one. Okay, and how are we gonna implement this? So it's gonna be in, we need this stuff, right? So we might have a while I should be the index, let's say, L is the length, let's do a loop, and I would say D is gonna be okay, it's gonna be a substring into S at index I and length of 1, and this is gonna be not really the digit, but this is gonna be the character. So we need another string, C string. So this is gonna be C, similar to this when we did digit. And now we need that if statement. So if C is equal to 0, then D is gonna be 0, 1, 2, 3, 4, and yeah, so on. Up until 9. And then we have the fees, right? So this gives us that. And now we should obviously increment I by 1 and probably build our number. So build our number by doing n is equal to 10 times n plus d. That's good. And after the while loop, pull and return n. So I think this should be it in terms of obviously we have some errors as usual. 49. Oh, we didn't increment inint. Okay, so inint should be in string to int basically. Yeah. Ooh, 81. Ah, but we defined it as L here. That sucks. Because I thought this, I mean this should override this one. I mean let's just do s.length and I'll have to check what that is about. Yeah, like to do weird bug cannot use L variable inlet. Yeah, I mean pretty weird. Okay, so let's see if the IO. Okay, perfect. So we have to go into prelude.asm and remove outInt and also inint. Okay, so this stuff still works. I mean, let's go into main.cl and let's test. Let's test like if it's integer, then x dot to string, right? And instead of doing read and write directly, let's append inint, I guess. Alright. I mean, x is gonna be, let's say, a new integer. Let's say x is equal to inint. And let's see, did that, this, okay, did this broke it for some reason. Prelude.cl. So, in int. Where is in? Int. So, two int probably broke it. I guess maybe it should be -1 or something. Still no. What? I mean, surely this while loop is what broke everything. Okay, what? '49. So 49. Ah, yeah, maybe we still had so if we comment out this part, it still compiles, but how? Why did it segmentation fault? Like toInt doesn't even do anything. I guess in string segmentation faulted. Oh, I guess so. Yeah, and I haven't checked if in string works. Yeah, so in string is actually wrong. I guess if we don't do this stuff, still seg faults. Wait, what? Mm, why would it segmentation fault on that? Wait, new string, isn't it like the default string? Okay, I guess new string doesn't really work. So I have to add another to do somewhere. New string was not, for some reason, I don't know. So let's bring back our, so like this thing. I mean, this doesn't even need to be initialized though. That's always funny. So why would that happen though? So we have in int when we append it. And that means I think is gonna be called there. So if we say like x is equal to this. Okay, so it happens inside of in int. So it might happen here, right? Yeah, it happens because of the while loop. Well, I guess we can do new io.out int I dot out string new line. Let's keep it like this. So out int didn't work this time. Man, it's really scuffed nonetheless. What? Okay, I mean, let's go to main.cl. Okay, let's see. So out int and out string like depend only on the Linux, right? So I think they should be fine. Let's test that. Out int 1. So it's mutation faulted. That's because here it needs to call to out to toString. So it calls to toString on the int class. Yeah, I don't get why this doesn't convert to... it's because it's inside of let. Alright, what's the problem? 118. So I put a comma. Okay, so it says 1 and it means that 1, 2, 3. Let's see if 1, 2, 3 is... Okay, yeah. So we fixed out int and out string probably. Yeah, like when I use new string it didn't work and I have no idea how or why that happens. I have to check inside of the like real code, inside of the compiler, how I handled like new string. But let's see. So now toString should work. Like we saw a few examples, so I think it's fine to assume that it works. toString on the integer. Alright, so now in string. Let's see if in string works, right? So we're gonna do, let's do first an out string, like that. Let's do an in string. And I guess we can have let or like straight up out string called on the in string, like an echo. Right, so hello. Okay, so works, right? So now let's see what happens in init. So we do to int on the string, right? So here I was trying to print I. So this should work now. We should be able to see the I. Not really, and yeah, it's not enough. Maybe let's see. Out int. Let's remove this entire stuff. Wait, what? Undefined method. Oh, a new IO. Okay, perfect. So I guess let's just remove all the extra crap from here. So it has length 4. Right, that's good. Right, that's really good. So here the digit should be null, I guess. Or I mean doesn't need to be initialized, because we initialize it here. So if we do substring, like if we do c is equal to s dot substring, and we do new IO outstring c, it's 1, so that works. Let's just remove everything, right? And let's IO, no, new IO dot out int, and let's show I dot out string line. 1, 2, 3, 4. That's good. But yeah, as I said, we should probably do -1 here. Although that should be handled when we read an integer. That should be handled when we read an integer. So maybe we should handle it inside of Linux read itself. But like if we just substring it, dot out string c, and we also take a look at that. 1, 2, 3. I guess it works. Oh, let's see, for example, what happens if we pass in ABC. So we have to remove the new line at the end. So let's maybe do an if. I would actually do a let maybe. Well, we can reuse temporary, so we can say, or like, have a C string. Say C is equal to s dot substring dot length minus 1. Yeah, and if C is equal to new line, then we remove, and otherwise it's gonna be S. Now if we do ASD, okay, and if we do like this, okay, so this removes the new line basically. Right. Well, we can do it like this to make it more look a bit better. But here we don't even need to do that. Right, and like this. Okay, so we handle that. Now it looks like when we pass in 1, 2, 3, everything looks fine. So let's now also print n. Okay, that's cool. So it means that we can actually l dot append x, and it works, right? So toInt also works. That's great news. Perfect. Okay, yeah, so the last thing would be booleans, but obviously like l dot append true, let's say. We don't handle the boolean, so let's say x. Oh, I have a better idea. What if we say x dot toString? And even then, we can just say l value, so out string l value toString. So we don't even need print actually. Yeah. And if we try to l append new object, it should say object or whatever. Yeah, like JavaScript. The last thing, yeah, I mean, I'll try to figure out why new string doesn't work. But yeah. Yeah, I mean, I'll have to figure out why new string doesn't work. And by that logic, new int doesn't work either, so yeah, because it's gonna be empty or something. So yeah, we actually improved quite a bit the standard library. We added toString, we implemented outString, outInt, inString, and inInt straight in here by using the Linux syscalls. So that's good. We also improved a bit this one. Yeah, still here it's a small bug, I don't know why, but it is what it is. We added conversion from, string, from object to string, and from integer, I guess from string to integer, parsing integers on strings, right? So we have to int, bam, easy. And yeah, I guess that's all for this one. Adding the read and write syscalls. That's pretty good as a start. So let's see if the checker still works. For case doesn't work. So for case didn't work. Let's see why it didn't work. Tests as 09 case. So this should be, let's see, 15. That's the first one. Then it should say boolean 1. And for the string, it should say 0. What? Oh, it's in out interpret. Oh my god. I know what's the problem. So when we convert the integer to string, right? Where is it? It's here. N is gonna be 0. So here, I guess, no, I guess it's like a special case before the while loop. If n is 0, then, well, I guess we can do here something like if x is equal to 0, then 0 else s. But we also have the case when x is negative. Okay, let's do it in a better way. So n will only work on positive numbers, right? So if x is more than 0, we apply modulo or absolute value. So let's implement abs, right? Let's implement abs and let's say x dot abs, right? So this one will work on x dot abs, right? If x is smaller than 0, we do that, okay? But we also have the case when x is 0. Like if x is 0, this won't run, basically. So if x is equal to 0, I think this is good. So if we rerun it, oh my god, okay. Unexpected minus 148. Oh, because it's this thing. Oh, what? Oh, you're annoying. So this should be case. Again, here should be tilde, whatever. Yeah, now it works. Okay, so checker. Great. So 17 has an issue. 17. Wait, what's the issue? Cannot execute format error. Wait, what? Hmm, that's really interesting. Let's see, 17. Let's not run it, let's just try to do that. Hmm, that's a new type of error. So let's see what 17 case example is about. Yeah, like it looks like it's an error with the new. Like even for is void, I see an error there. A is void. What? Okay. But then why did it complain? Now it complains in 16. Okay, let's. Let's do make clean. Let's remove the stuff from TMP. I guess do whatever. Yeah, so that wasn't an issue. It's an issue with 17.cl. Yeah, this is... I guess this is really strange. Fuck you, don't buy. That's... I mean, I don't see how it's... No, I didn't see anything like comments or stuff. Let's see, file main. Yeah, I guess no clue why that happens. Build main. Oh, so now in main, no in yeah. I guess the new main file is no longer the new main file, I guess. I guess this is the new main file. You can leave. Oh well, well. Let's still keep our Johnny boy. Who likes to eat pizza? Okay, so we don't no longer need this thing. And I guess if we move to string on this one, okay, and this. Wait, we didn't append the l.append guy. And like it still works. So now I'll just have to figure out why, so I can delete these. Yeah, I'll try to figure out why that happens. Like I added some to do, so I'll try to fix them. But yeah, I mean, obviously, by deleting the temporary files, something broke. Feature introduce bugs. That's a nice feature. Okay, yeah, I mean, I guess we have made some progress, and we also made progress in the reverse direction, but now we have a nicer, let's say, standard library, right? With less external functions. I guess that's what I'm trying to get at. So yeah, I guess I don't know. This was good. Like now we can use read and write syscalls. So that's nice. Maybe we'll try to implement more, and I'll try to fix the issue that appeared. So yeah, see you in the next one.